Welcome to the fourth revolution.
The new wave of industrialization and technologies is the combining of cyber-physical systems, the Internet of Things, and the Internet of Systems. At its base lies the idea of web connectivity between machines, which ultimately leads to their ability to communicate and make decisions on their own. These technologies, from the physical, digital, and biological worlds, will have a massive impact on our lives and will bring to the forefront some advantages and great challenges. Humankind has faced three successive waves of innovation. The first revolution, mechanization. In the late 18th and early 19th century, machines started to take the burden off animals and people, replacing agriculture as the foundation of most economic structures. The second revolution, mass production. Nearly a century later, electricity, gas, and oil boosted the capacity for manufacturing, as well as the long-distance transport via rail and steamships, and later the automobile and planes. The third industrial revolution, automation. In the later part of the 20th century, new innovations such as computers, cell phones, and the internet further advanced industries. And the fourth revolution. This aims to connect all production means and allows them to interact with each other. Thanks to technologies such as the cloud, big data analytics, and the Internet of Things, communication among all players is made possible. The next step beyond mechanization is robotization. Now machines can perform more complex tasks and are able to adapt. This development has an impact on all disciplines, economies, and industries, and even challenging ideas about what it means to be human. Military. The future of technology will be most visible in the military, and the promise of advanced weaponry and more effective fighting styles keep the funding of defense programs alive. According to Lieutenant Colonel Robert S. Farrell in the United States Army, automation on the battlefield with digital technologies will produce greater fighter effectiveness through better use of resources. This technology ranges from simple to complex. Nano-sized tracking systems to fully automated tanks are already implemented as standard warfare tech. Traces of mechanical suits are already being tested in the field. Talos, the Tactical Assault Light Operator suit used by U.S. Marines, is the start in the upgrading of uniforms and body armor. Covering 60% of the wearer's body, Talos is designed to be lightweight and bulletproof, with integrated communication and sensory tools built throughout. A shield, activated by electricity, acts as a liquid body armor, which can turn the suit solid in an instant. It essentially creates a cage of bulletproof electricity, allowing the wearer to complete tasks otherwise deadly to the average man. With technologies advancing quickly, the next step is to create entire platoons made solely out of automated robots, either taking decisions from a secure location or having the ability to act on their own. The ability to wage war is significantly easier when there are no lives being lost. Virtual reality. Have you ever wanted to see the world, discover new things, see wild animals up close and personal? This is now possible from the comfort of your own home with the help of virtual reality. Travel has become a lot easier with the help of VR. The traditional high street travel agency has been replaced by online agents, websites, search engines, apps, and aggregators. This idea of exploring new places from afar has made virtual reality particularly appealing to parts of the travel industry. Wouldn't a free virtual reality tour of the Colosseum eventually help a tour operator sell more holidays to Rome? What about a peek inside the city's most luxurious resorts, with the chance to look around the rooms, take a stroll through the restaurant, garden, or the gym? This might seem far-fetched, but the technology is already capable, and the ideas are already being tested. Not just by experimental young companies in Silicon Valley, but also by some of the travel industry's biggest players, like Thomas Cook and TUI. Pilots are using it as flight simulators, geologists are using it to survey vast landscapes remotely, both here on Earth and in the solar system, and architects are using it to show people around buildings that are years away from completion. Medicine. An interesting technique one might not find in the medical field is 3D printing, which already has massive potential in the rendering of transplantable organs. Advancements have enabled printing of biocompatible materials, cells, and supporting components into complex, functional living tissues. This technology can also be applied to future training for medical professionals, with lifelike visions of what they'll deal with in their fields. Doctors are not printing models, but working tissues, organs, and bones. A further innovation present in the medical field is the possibility to design a baby. The most advanced medicine uses nanotechnologies and embryo modification techniques, and through the customization of genetic material from the beginning of development, physical traits to cognitive abilities can all be manipulated. Scientists have already accomplished the pre-implantation genetic diagnosis screening, PGD for short, as well as the gender selection of a future baby. Embryo screening is already in practice. This is the process of examining the DNA of embryos using PGD. After embryos are created with an in vitro fertilization process, they grow into the 8-cell stage. There, 1 or 2 cells are removed. These cells are then examined by scientists for defects, and only healthy embryos are placed back into the womb. The future of humankind could be designed on an iPad.